So in this video we are going to discuss trigonometry up to transformations, exercise 6F. The question is, if ABC are angles in a triangle, then prove that. First question, sin 2A minus sin 2B plus sin 2C is equal to 4 cos A cos B sin C. See how to prove this is. Here, so ABC are angles in a triangle. Given that when ABC are angles in a triangle, so we know that sum of the angles A plus B plus C is equal to 180 degrees. So from this we can write A plus B is equal to 180 minus C, and also we can write C is equal to 180 minus of A plus B. 180 minus of A plus B. Now taking LHS here, so we have LHS, so that is sin 2A minus sin 2B plus sin 2C. See, considering the first two terms here, so which is in the form of like sin C plus sin D, sin C minus sin D here. So sin C minus sin D, so we have the formula, so 2 cos C plus D by 2, 2 cos C plus D by 2 into sin C minus D by 2. See what is C here? Completely 2A is C and 2B is D if you consider. Now which can be written as, so 2 cos C plus D by 2, that is 2A plus 2B by 2. So here sin into sin C minus D by 2, that is 2A minus 2B by 2, and plus sin 2C is writing as it is. See, if you take 2 common in the numerator, 2 gets cancelled. So we get here, so 2 cos of A plus B, 2 cos of A plus B into sin of, here also 2 gets cancelled, sin of A minus B plus sin 2C. So see here, A plus B is, we know that 180 minus C. So that's why here cos A plus B is replaced by 180 minus C into sin of A minus B and plus sin 2C we have here. See, if you observe that cos 180 minus C is like cos 180 minus theta. So here cos 180 minus theta is, we know that minus cos theta. So that's why here, which is equal to 2 into cos of 180 minus C is, we can write minus cos C. So that's why this is 2 into minus cos C is nothing but minus 2 cos C into sin of A minus B into sin of A minus B plus sin 2C, writing as it is. Now see, if you observe here, here cos C is there, here sin 2C we have. So now sin 2C is also can be written as, so that means it is like sin 2 theta. So we have sin 2 theta is 2 sin theta cos theta. So that's why here, so which is equal to minus 2 cos C into sin of A minus B into sin of A minus B, and here plus sin 2C is writing as like sin 2 theta. So 2 sin theta cos theta, here 2 sin C cos C. See, observe here, in both the terms we have 2 cos C is common clearly. If you take 2 cos C common in the first term, so we have minus sin A minus B is left over, and in the next term we have, after taking the 2 cos C common, so we have sin C. Now again C we have here 180 minus of A plus B, so that's why here 2 cos C. So this is minus sin of A minus B, and here sin C writing as 180 minus of A plus B. So now we have here, so C is replaced by 180 minus of A plus B. So we know that sine 180 minus theta. So what is sine 180 minus theta? Sine 180 minus theta is equal to, we know that, sine theta. It is belongs to the second quadrant, but sine is positive, so sine theta. So now which is equal to 2 cos c into minus sine of a minus b, and as per this property we can write here plus sine a plus b. See, if you rewrite this is like suppose we get, so 2 cos c into, this is sine a plus b, sine a plus b minus sine a minus b. See, sine a plus b plus sine a minus b, what is the formula? So sine a plus b minus sine a minus b, sine a plus b, sine a plus b minus sine a minus b. So we have the formula, that is 2 cos a sine b, 2 cos a sine b. So that's why this entire thing within the bracket is replaced by this formula we have, sine a plus b minus sine a minus b. So that is 2 cos a sine b. So here 2 cos c is writing as it is. So into here, so this is 2 cos a sine b. Now finally what we get here, which is equal to 4 cos a sine b cos c we get. So in the right hand side what we have here, 4 cos a sine b cos c. So like this we can prove, which is equal to RHS. So therefore LHS is equal to RHS. So hence proved.